بسم الله الرحمن الرحيم. قالوا سبحانك لا علم لنا إلا ما علمتنا إنك أنت العليم الحكيم. We continue our part 2 of the video about reviewing the rectifier and the clipping circuit. Section 9.6 and 9.7. Last thing we stopped at was peak inverse voltage in case you have capacitor connected to the load. So here we have capacitor connected to the load. As we know, the voltage across the load is this red line. This red line is the voltage across the load VL. Tamam? So the diode is on in this time. During this time, diode is on. During all this time, diode is off. So the diode is off when the voltage of the input start to decrease than V maximum. What about when the diode is off? When the diode is off, what is the maximum voltage across the diode? So the question is, when the diode is open circuit, this diode is open circuit, shabab. Diode here is open circuit. When the diode is open circuit, what is the maximum voltage across the diode? It is the voltage at this point. Look at this point down here. The voltage when the input is negative V maximum. When the input goes in the negative cycle, diode is off. In this case, what is the voltage across the capacitor? Look here. Look at this point, shabab. Voltage across the capacitor close to V maximum, approximately V maximum, and a little bit less than V maximum. So I will assume the voltage across the capacitor is positive V maximum with this polarity, as you can see here, and the voltage across the input is negative V maximum. So this is a correct polarity. Now I am at this time. Look here, look at this line. I am here. When the input is negative V maximum and the voltage across the capacitor is V maximum. What is the peak inverse voltage in this case? Simply the peak inverse voltage, the voltage across the diode, when the diode is open circuit, is twice V maximum. Just take KVL in this loop. Take KVL in this loop. And find the voltage VIV. Find VIV. VIV will be simply 2V maximum. This is called the peak inverse voltage. It's important to know this voltage because the diode in breakdown, you know, when the diode is in breakdown, we need the diode. When the diode is off, the diode must be working in this region from this time to this time. So we need the breakdown voltage, the Zener voltage, to be bigger than the peak inverse voltage. Yani VZ must be bigger than the peak inverse voltage. So the diode will never go in the breakdown. The diode shouldn't go in the breakdown. Peak inverse voltage is always positive. So VZ must be bigger than VIV. This ensures that the diode will be in this region only. We need to make sure the diode will be in this region and will never go in the breakdown. This is the reason we are interested to know what is the peak inverse voltage. Again, the VIV is the maximum voltage across the diode when the diode is open circuit. Tamam? This is the full wave rectifier. Again, in the full wave rectifier, as you can see here, when the input is positive, so when the input is positive, positive means we will have this polarity for this source. And we have the same source here. We have two sources. So this diode will be on. The other diode will be, the current is coming this way. This diode will be off. Remember, this resistor is like here. And assume the resistor is here. If you remove the ground, or keep the ground actually, and the resistor is something like here. Tamam? Yani you can remove the resistor from here and have it here. So when the input is positive, diode A is on, this guy is off. What about when the input is negative, in the negative half cycle? Which one is on, which one is off? So now the input is negative, both input. Yeah, and this guy, the polarity here will be like negative positive, this guy is off. And here like negative positive, this guy is on. In both cases, the current is going this direction. Remember, yeah, in both cases, whether the input is positive or negative, listen ya shabab, whether the voltage source is positive or negative, the input, the current in the diode is going down. This means VL is always positive. So we will have like full wave rectifier as we can see here. Tamam? This circuit is another version of full wave rectifier. We call it center tap. Center tap means you have one big coil as the primary coil, الملف الابتدائي, one big coil, and the secondary coil, which takes the energy on the other side, is splitted. So we have like two sources. Yani this circuit is the same as this circuit. We have here two sources. And the two sources will have the polarity based on the input voltage. So when the input is positive, this is the polarity. When the input is negative, down here, the polarity will reverse. So in the first case, when the input is positive, the first diode D1 will be on, D2 will be off. So the voltage across the diode will be, as you can see here. Now, when we reverse the polarity of the input, so this input Vs and the other input, both of them will be reversed. D1 will be off, D2 will be on, exactly as we said in the previous case. Tamam? In the bridge rectifier, so as you can see here, when the input is positive, the current will go in this diode, then in this diode. This means V out is positive when the input is positive. What about when the input is reversed? When the input is negative, look at the current goes in the two other diodes. Tamam? So the bridge rectifier is a circuit that has 4 diodes. 2 of them will be on at a time. 2, يعني here, when the input is positive, diode A, diode B is on, C and D are off. And when the input is negative, it will be the other way around. So as you can see here, this nice video, nice animation. It is clear that V out is positive. Look at the current in the R. The current means, the current direction means that V out must be positive value. In the other way, when the input is negative, on the other side, D3, D4 are on, D2, D1 are off. In this case, also V out is positive. This is very important, Shabab, to understand that V out in both cases is positive. And regardless of the polarity of the input, positive or negative, V out is always positive because the current always comes in this direction. Tamam? In this case, the capacitor needed to do smoothing will be half the value in half wave rectifier. Look at this value. This value is 1/2 times the value we used in half wave rectifier. In half wave rectifier, we don't have this 2. But here, because we have full wave, we will have 1/2. This means it's better. The behavior here is better because here you have like full wave rectifier. So the capacitor, when the capacitor charge and discharge, you will have better performance. Look here. Look at the ripple. The ripple is less. You have smoother this signal. You have smoother signal. I think you can read this example, or let me review it quickly with you. So here in this circuit, now we are using the diode to connect the source to this DC battery. This is like charger. And what we have here is a charging circuit. Charger or charging circuit. Tamam? Charger or charging circuit. So during the positive half cycle, when the input is positive, this diode will be on or off. It's based on the value of the input. Actually, as long as the input, yani if the input Vs less than Vb, diode is off. Vb is the voltage here. Yeah, the voltage across the diode here is the source minus Vb. The voltage across the diode, Vd is always Vs minus Vb. So it's clear that the voltage across the diode is controlled by the source and Vb. So the diode will be on when the input exceeds Vb. So only during this time. Only during this time you will have diode current. This is the diode current here, ya shabab. Yani the diode current is this current here. Diode current will flow between T1 and T2. Between T1 and T2. So we'll have the diode current this way. Okay. Diode current will flow only between T1 and T2. The question is, what is T1 and T2? T1 will be when this equation is satisfied. So V input, yani V maximum sine omega T, omega T1 must equal to 14. When Vs equal, this is the time T1 is the time here. Tamam? When V input equal to Vb, and Vb is 14. 14 is Vb. V maximum is given as 20. So we have one unknown like T1. تمام. Omega is 2 pi over T or 2 by F. F is 1 over T. What about T2? What was the time T2? Any idea what is the time T2 يا شباب? Time T2 will be simply omega T2. Omega T2 will equal to pi minus this value. Yeah. Let me look at this equation here. Look at this. This is the first equation I have said. So from this equation, it is clear that omega T1 will be 0.7754. Then omega T2 will be pi minus this value. Omega T2 will be pi minus this value. Why we have pi here? We have pi here because this pi is the point here. And here the omega T is equal to pi. And at this point, omega T equal to pi of the cycle. Okay, omega T equal to pi at this point. So omega T2 will be pi minus 0.7754. Because here one half cycle like pi, another half cycle like pi. تمام. Then from these two equations, from this equation to this equation, you can calculate T1 minus T2. Easily, you can find T2 minus T1. Okay. Here, I believe this is easy for you to read. Here it says that a power supply is needed to deliver 0.1 ampere and 15 volt. What is the 0.1 ampere? 0.1 ampere is the current here in the load. This is the current IL. تمام. And the 15 volt is the V load average. يعني V load average means the load voltage average. V load average is 15. تمام. And IL is 0.1 ampere. Frequency is 60 hertz. In this case, assuming the diode has forward bias of 0.7, and assuming the diode is not idle, it has forward bias. When the diode is on, it will be replaced by 0.7 volt. What is the value of the capacitor needed to? What is the value of the capacitor needed to have VL average equal to 50? تمام. Assuming V rebel equal to 0.4. And as you can see here, the rebel voltage equal to 0.4. يعني VR equal to 0.4. This means VL average, it should be, it used to be V maximum minus V rebel over 2. We have this equation before, right? V maximum here is given as 15. It's not 15, it should be 15.7 because the diode has 0.7 voltage. And V maximum here will be replaced by like 15.7 minus VR over 2. VR over 2 will be 0.4 because VR is 0.2. VR is 0.4. So VR over 2 is 0.2. In this case, and VL average is 15. تمام. I think there's something here. Let me write the equation again. So here we need to have the forward drop across the diode is 0.7. This means V maximum will be, we need to design peak voltage of 15.2. So this means the voltage across the capacitor. The voltage across the capacitor, يا شباب, is going this way, then going down, then going down, then going this way. This means the average voltage the average voltage here, this average voltage is said to be 15. تمام. variable, this distance, this voltage is 0.4. So what should be the maximum here? Should be 15.2. It's clear, I guess now. That's the peak. Even it says that we need the peak load voltage to be 15.2. The peak load voltage is 15.2. This means the input will be 15.2 times 0.7. 0.7 is the die. Because after we drop 0.7, the output here will be 15.2. And the input must be 15.9, which is this value. In this case, we can calculate C as IL. IL is given here. C is IL times T. T is 1 over 60 over VR. تمام. So we need, here's the problem, need to find the peak EC voltage. The peak EC voltage is 15.9 as we calculated. Again, let me summarize the solution. So the voltage across the capacitor needs to be something like this. تمام. Variable is this value, which is given as 0.4. We need the average. It says that the average will be, the average voltage need to be the average of this rebel, this value need to be 15. This means the peak voltage here, this 15 is in the middle between the maximum and the minimum. So the maximum here is 15.2, which is the problem already given. This means the input will be, the voltage here is 0.7, and the maximum here is 15.2. The maximum voltage across diode, 15.2. This means the input will be 0.7. The maximum of the input, the maximum will be like 15.2 times 0.7. تمام, which is 15.9 as given here. I hope it is clear now. Now we go for, this is the main component of the DC power supply. So what is inside the charger is all of this. All of this is inside your charger. We have diode rectifier. So we have EC voltage here. The difference between this EC number 1 and the number 2 is that the amplitude is much less of number 2. The voltage at number 2 is much less. Because the government electricity is 120 volt. This is the electricity we get from government. We need to make it lower because your mobile phone work at 5 volt. Then we have rectifier. The rectifier will produce full wave rectifier. Then we have filter capacitor to smoothen the signal. Voltage regulator, which is like Zener to fix the output at like DC, pure DC. And the load is like your phone. The load here is your phone. تمام. This is another, this is implementation. So how to design the whole power supply? We have circuit 1, circuit 2, and circuit 3. We have 3 circuits to design the power supply. Now we move to an important topic, which is the clipper or clipping circuits. In clipping circuit, we will have the input. So the input is always EC, something like this. This is the input. So the input is this red signal. This is the input. We need to see what is out. So how can we solve this? We need to assume that the input is positive. So when the input is positive during this time, the polarity is as given. تمام. when the input is positive during this time, polarity is correct like this. This means the current in the diode will be this direction. So this guy is on, the other guy will be off. تمام. this branch is off, no current here. So the diode A is on. Diode A will be replaced by 0.6 or 0 volt. So V out will be either 6 volt or 6.6. Here, assuming idle diode. The diode is idle, Idle diode means the voltage V out will be 6 volt. So again, when the input is positive, the current goes this way. Diode A is on. This guy is off. So diode A is replaced by short circuit. This means V out equal to 6 volt. This means V out here equal to 6 volt, which is output here. When the input is negative, now when the input is negative means this will be negative, this will be positive. Now the current goes this way, so diode A is off. Forget about diode A and this branch. The current go here. It will go easily. This will be like short circuit. Now what is the out? -9. So we need to have -9. So the output يا شباب is like the output is clipped, limited, limited circuit. So we can limit the output to be only between 6 and -9. تمام? What about the transfer function, V out versus V input? The transfer function, as you can see here, V out is the same as V input when V input is between 6 and -9. And during this time, this part is here. From here to here, this means V out is the same as V input. Once V input exceeds 6 or V input exceeds -9, in this part, the output is limited to 6 and -9. And what I'm saying here is during this time, all this time, V out same as V input. On the other side, V output will be limited with 6 or -9. This is the Shabab V out versus V input. Okay, so in this kind of problem, very easy. You need just to see when the input is positive, where is the current? Where does the current go? And when the input is negative, where does the current go? And based on the current direction and the current path, you can easily decide which diode is on, which diode is off. Now, let's see. Here I have diode and zener, When the input is positive during this time, where is the current? This is the voltage polarity. Current will go here. Can the current go here? Yes. This guy will be on, this guy will be breakdown. Current can go here? No, this will not be off. This will be off. So what is the new circuit? The new circuit is the source connected to R. The diode will be replaced by, say, 0.6, the first diode. The zener will be replaced by a battery 5.4. Look, Shabab, this is a new circuit. So here, as you can see here, the zener is replaced by this battery. And the diode is replaced by this battery. So you have diode and zener. Each one is replaced by its own battery. Now, what is V out? V out is clearly 6. So V out is 6. Tamam? Similar to the previous example. When the input is negative, during this time, when the input is negative, where does the current go? Now, when the input is negative, tamam? During this time, input is negative. The polarity will be negative here, positive here. So the current can the current go here? Never go here. So this guy is off because of the diode. The current can go in the zener, but it will never go in this diode. Can the current go here? Yes. So what is the new circuit? This will be replaced by, okay, Shabab, here at the polarity, not the other way. Look at the polarity. So the diode is replaced by 8.4 plus 0.6. So what is V out, ya Shabab? What's V out now? Clearly -9. So V out will be -9. So similar, the output here is similar to the previous circuit. 6 or -9. 6 or -9. 6 or -9. So this circuit is doing the same job as the previous circuit. Tamam? But the new circuit has no source. Here I have 6 volt and 9 volt. This money. 6 and 9 volt are money. Here I replace the 6 and 9 volt by 2 zener. Can we have better circuit? Yani, can we remove 2 diodes here? Can I remove this and still have the same output? Yes. Look at this new magic, new circuit. This circuit will give you the same output. So we have the same circuit actually. Yani A same as B. How this can take place? Let's see. When the input is positive, the current will go in this zener. The first zener is on. Second zener is breakdown. So first zener is replaced by 0.6 because it is forward bias. Second zener replaced by 5.4. What's the out now, ya Shabab? The out is 6. Same as here. Same as what we have done in the previous circuit. What about when? But look at the polarity. And here, please pay attention. Look at the polarity of this guy and this guy, and the other guy and the 5.4. Look at the polarity. Please don't mix. Don't switch. What about when the input is negative? When this input reversed like this, current will go, first diode is on, forward bias. Second diode is reverse bias. So what is the situation now? And the current will complete. The first diode is replaced by a battery with this polarity. The second diode is replaced by a battery with this polarity. So what is the voltage? 8.4 plus 5.4. I think I have a mistake here. What is the mistake here, Shabab? Look at the values I have here. Is it correct? 8.4, 5.4? Where is the mistake? This is not 8.4. This is 0.6. Sorry. Seems the other way around. So the values I have here, the correct value must be, the correct value is, the first diode is replaced by 0.6. The other diode is 8.4. Because the first diode is forward bias. This guy is forward bias. Look at the other guy. Look at the polarity. Very important. So V out now is -9. So as you can see, we can have circuit, يعني this circuit, number A, number B, and the C, all of them will give the same output and also same transfer function. Okay, so we can design better circuit, يعني to save money, to get rid of this two battery. Battery means money. You need to buy batteries. But when we remove them, we can have only one zener, two zener. Two zener will do the job. The last circuit, only two zener. Okay, Shabab? Now, let's see. When the input is positive, when the input is positive during this time, when the input is positive, where is the current? This is the correct polarity. So the current will go here. This guy is okay. This guy is off. Current will never go here. So what is the new circuit? Diode is replaced by 0.6 and the zener is replaced by 9.4. Look at the polarity. Look at the polarity again. Plus, negative, plus, negative. What is V out, Shabab? V out equal to 10. So in the first half cycle, V out equal to 10, as you have seen. What about when the input is negative? So the polarity is like this. Can we have the current here? Never. Because of this diode, because D1 will never allow the current. Can we have that current is other guy? Yes. So what is the new circuit? The new circuit is to replace this yellow guys, replace this by forward bias, 0.6 plus 0.6 plus 0.6, which is 1.8 with negative value. So the new circuit is 0.6 plus 0.6 plus 0.6. This will give you 0.6 plus 0.6 plus 0.6. This is negative 1.8. Negative 1.8. V out. So as you can see, we can play with output. We can shape the circuits. Very nice. I love these circuits, because it has many innovation. You can easily play with this. So, replace the diode by another diode by another. Have another diode here, maybe another diode you add here to control the voltage. We can play with many stuff here. Now, we have something new here. We have a resistor. The previous guys, we didn't have this resistor. What is the situation? What does the resistor do? The resistor will produce output which is not clipped, is not DC here. The output will be like, have the same behavior as the sine wave because of the resistor. How does this work? Let's see. When the input is positive, look at the input. When the input is positive, the input has maximum of 15. The current will go this way. So the new circuit will be, what will be the new circuit when the input is positive? This guy will be replaced by a resistor. The first diode is replaced by forward bias. So we have 0.6. Second diode is replaced by breakdown. Second zener, sorry, 4.4. And then we have R. This is the circuit. So what is the current now? What's the current in the 1K? And here the current is 1K. Assuming the input is 15, the maximum. Assuming the input here, Shabab, is 15. What is the current in this circuit? What's the current? The current is simply, the current is 15 minus 5 over 2K. What's this value? 15 minus 5 is 5 milliampere. So the current is 15 minus 5. Let me fix this 15. The current يا شباب, as you can, the current in this circuit. The current here in the circuit. This current here. This current. Or this current here. Same current. Equal to 15 minus 5 over 2K. Which is 5 milliampere. So what is the voltage now? What's the voltage V out? Let me delete everything. We agree that the current here is 5 milliampere. When the input is positive, during the positive half cycle, the current is 5 milliampere. So what is V out? Again, this circuit is 0.6 here, 4.4, and the resistor. The resistor has current of 5 milliampere. What is V out? V out is 0.6 plus 4.4, which is 5. So V out will be 5 plus IR. V out in this circuit يا شباب is 5 volt plus IR. Remember, I is 5 milliampere and R is 1K. So V out will be 10. Look at this value here. V out is 10. So V out will take the same behavior as a sine wave. It will not be clipped. It will not be straight line like before. Look here. Look at the voltage here. Because we don't have resistor in the output. But here, because we have resistor, so we will have this behavior. In the negative, same. So here we can have this behavior, and the transfer function V out versus V input will be as long as output less than the input less than 5, V out equal to V input, because both diodes will be off. Then you will have like a slope 1/2. The slope here is 1/2 because of the behavior here. V out when this guy is 15, it will give you 10. يعني what I'm saying is, look at this point. When the input is 15, V out is 10. From where I know this point? From here. Here. When V input is 15, V out is 10. So I know now 2 points here. And I know 1 point here. So I can draw this straight line. It will be 1 to 2. Here, شباب, the slope here is 1/2. Because it is clear here, as you can see, and if you take this 2 point, here the difference is 10, and here the difference is here along y-axis. What is this voltage? 5. So it's 5/10, means 1/2. This is the reason we have here 1/2.